In this problem, we are going to go over how to take a word problem and translate those words into a standard form of a linear equation. Let's dive into it and see why the standard form of a linear equation is the best way to go here. So it says you go to a baseball game and are hungry. Sweet. That first sentence means nothing, and well, we're not going to translate anything from it other than you're hungry. Hot dogs cost $3 each and soft drinks are $4 each. So like right away, I'm thinking, like I'm just translating along the way that I might have like $3, let's do 3x and 4y. And I'm going to define what x and y are. It's just something that comes up in my head. 3 per number of hot dogs, $4 per number of soft drinks. So x equals, and I'll just put number of hot dogs, and y is going to be equal number of soft drinks. So I'm just going to say number of drinks, specifically soft drinks. Okay, we'll keep reading now that we've translated that. You have $24 on a gift certificate and wish to spend it all. Okay, it's starting to come together here. The total is 24. So I'm just going to kind of put my thoughts here. It's just doing some brainstorming, equal to 24. We'll do a little bit more math in a second. Find two different combinations of numbers of hot dogs and soft drinks you can buy. So we want to know the number of combinations of hot dogs and soft drinks we could buy. Now, we could do this without algebra. You could just kind of mentally go through it and be like, well, if I want to spend $24, what happens if I have like 6 hot dogs? Then how many soft drinks would I need to buy? You could do it that way. We're going to do it with standard form of an equation because it gives you the formula that we need to find all the combinations. And then it says write an equation in your solution process. So here's the thing. If I buy a certain number of hot dogs and a certain number of soft drinks, well, not hot drinks, right? I would add the number of hot dogs plus the number of soft drinks, those amounts of money together to give me 24. So the number, well, the amount of money that hot dogs cost would be $3 per the number of hot dogs plus $4 for each soft drink. So this would be the amount of money we spent on soft drinks. And if I add them together, I want to get out $24. Oh, so we started out the video saying we'll see how or why a standard form of the equation would work best here. It's not necessarily that it would work best, it's just that is what the situation translates into. So it's a good thing we understand intercepts now, right? X and Y intercepts. So now from here, to find two combinations, well, there's 2 points that are really easy to find on a graph like this. The X and Y intercepts. So that's what we'll do, and that'll give us two combinations of numbers of hot dogs and soft drinks that you can buy. So I'm going to find the y-intercept, so I'll let x equal to 0. That would give me where the y value is equal to something. So graphically here, peeps, what we're doing is we're basically finding the point on the y-axis when x is 0. So I'll plug in x equals 0. I have 3 times 0 plus 4y equals 24. So the whole purpose here is we're done with the word problem translation, peeps. Oh yeah. So I'm left with 4y because 3 times 0 is 0 is equal to 24. And then from here I divide both sides by 4. So that will give me the amount of soft drinks I can buy with $24. So y is equal to 6, which is the point 0, 6. Because remember, we plugged in 0 number of hot dogs, x, and got out the number of soft drinks. So let's say that's like right here. Okay. Just a random graph, a rough graph. Now let's find the amount of hot dogs we can buy if we don't buy any soft drinks. You'll be pretty thirsty, but we can do that. That's if y is equal to 0. That would mean that we didn't buy any soft drinks. Well, that would mean that we have 3x plus 4 times 0 is equal to 24. And now from here what we can do is we can just solve for x. So 4 times 0 is 0. 3x is equal to 24, and now I divide both sides by 3. So if I divide everything by 3, I end up with x equals 8, which is the x-intercept. 8 comma and then 0 for the y value or the number of soft drinks. So 8, 0 is somewhere over here. And why do I show those 2 points? Well, because those are our 2 answers. So if I'm answering this question out, I'm going to say we could have 0 hot dogs. So I'll say 0 HDs. And 6 drinks. That's this combination. So it's one combination. The second combination we could do is 8 hot dogs, 8 HDs, and 0 drinks. And that's just from the x and y intercept. If you were to connect those 2 points, and I'm not going to connect the line past these because you can't have negative x values, you can't have negative hot dogs, and you can't have negative drinks, right? So we're just going to connect those dots. Any points on this line that are nice integers, because you probably don't want to buy half a hot dog or half a soft drink, would be other solutions. So for instance, just spitballing here, I could have 6 hot dogs. That would give me $18 total. And then, well, no, that would give me a part of this, right? That wouldn't work. Okay, well, guess that doesn't work. Well, maybe I could do, maybe I could do 5 of these or 7 of these. Yeah, I could do 7 of these. That would be $21. Oh, and that would give me a part of a hot or soft drink. So the point being is, if you plug in different values for x and y along the way, like plug in x equals 1, you'll get 3, which leaves you with $21, and that's, well, 4 doesn't go into that. You could start testing and seeing what other points are on this line. Point being is, we solved it just by finding the x and y intercepts, nice and easy, and we saw how beautifully the standard form just came right out of that word problem. Awesome stuff. See you in the next video.